everyone. So it's very nice to meet you all.
I was actually skeptical about these kinds of workshops, and particularly when it involves a large part of the audience on a very specialized subject. But I was proved wrong. When I came here, I was skeptical, but when I'm leaving, I'm actually leaving with a very, very positive note. I was telling both Uday and Divyendu that we should do more of this and we should do this every year.
This has been a great experience, and I've been wanting something like this to happen for a very long time. And I look forward to this becoming an annual gathering. The fact that it's driven by practitioners and there's a large number of practitioners in the audience, that makes the session lively. People have been asking lots of questions, so I'm extremely happy that people have come forward to arrange this, and I would like to support this in whichever way possible in coming several years.
So I would like to add that this would actually make more interactions happen between practitioners and researchers, and a very, very good possibility of having a lot of collaboration and very exciting time. The other thing that I wanted to say is also that getting this to the students, right, is also equally important, because we need to spread the word, and we need to have the students excited about it, because they have to eventually come and work more and more on compilers. So from all angles, it's a win-win kind of a thing. Thank you.
It's just really wonderful to have so many compiler engineers and enthusiasts under the same roof, even the practitioners. Kudos to everybody who organized this, and please continue doing so.
Oh, it's fascinating, this kind of collaboration of industry, research and academia is very nice to put together in a place like this. It's good that, it's great that the team could put it off. It's very nice. Thanks to the team. Please keep it.
Yeah, I have been attending LLVM Dev for quite a few years now, and I never guessed that we'll have LLVM Dev kind of experience here in Bangalore itself. And I think the energy and the interest was, you could see it from very early in the morning, and all the talks, it was all full, a lot of questions, interactions. I think it's wonderful, and I should thank the organizers once again, and I think there's so much good participation. I should continue it at least for many years to come.
So I got into compilers because I had a very influential teacher by the name of Mr. Sapre, who taught us compilers when I was doing MTech, and I realized that studying this is very, very enjoyable. Then I did my PhD with Professor D.M. Dhamdere, and I learned lots of new insights about compilers from him. So I'm basically indebted to these two people, Professor Sapre and Professor Dhamdere. And then I had great colleagues working at IIT Bombay. So we're working on some very interesting problems. We're asking deep questions, and that's a fun experience working on compilers.
I was a student, MTech student in IIT Bombay in 1990s, 1994 to 96, and my MTech advisor was Professor D.M. Dhamdere, and he was working in compilers. He was one of the pioneers of compilers field in India. So I did my MTech project with him. It was generating an optimizer as part of a compiler. So that work was very exciting, and he had a set of good students, senior students, who guided me, and that really made me very interested in compilers.
See, how I started with compilers, this is not something like a love at first sight. This was more like, it's like more like poha. You get poha because the poha, you are hungry, you get poha, and then you start eating. The more you eat, the tastier it becomes. And then now I find the poha is actually very nice. I have it for breakfast, lunch and dinner, right? Yeah.
why did I start working in formal verification and formal methods in general? That's a long story, but to summarize it, it's really the combination of theory and practice both coming together. So I think this is one of the areas where you need one foot very firmly in theory and one foot very firmly in the practical aspects of it. And this is something that appeals really to me, so that it's not just theory that we work out, proofs we work out just for the heck of it. I mean, that of course has its importance, and it's not just systems we build by just hacking into something, which also has its utility. But I think this is a nice meeting ground for both of them. And my initiation segueing into this happened through my PhD advisor, Professor David Dill, who has pretty much taught me all I know in this area, and that's how it all started. Yeah. So I mean, it's really the meeting ground for theory and applied work that really makes me work in this area.
Actually, after finishing my PhD was mostly in architecture. I went for my postdoc, and in the second year of my postdoc, I was interacting with my postdoc mentor, Professor Guang Gao, and that is where we started looking at some compiler problems, particularly problems on instruction scheduling, software pipelining, and related things. Then I kind of got introduced into this area, which is the interface between architecture and compilers. That's where I got introduced into compilers. I cannot call myself as a core compiler person because I don't do many of the other things in compilers. But over the years, I have done more work on compiler optimizations, more on the back-end machine-dependent optimizations. And then a couple of my students taught me how to do program analysis, pointer analysis, and other things. So I learned a little bit from them. So that's how I got introduced into compilers.
Yeah, so how I got started with whole this formal verification program analysis, it was quite serendipitous. So I got admitted into IIT Bombay as a research assistant, and as part of my research assistantship I was RA with this Center for Formal Development and Verification of Softwares. So that means that my MTech thesis has to be aligned with the vision of the center, which was to do things in verification, and that's how I got introduced to this wonderful world of formal verification. And I kind of got hooked onto this world because you are trying to mathematically and rigorously argue about systems, their behavior, and trying to prove it safe, and maybe make the world a safer place. So yeah, and that's why I got interested into formal verification. And then later on I explored various relevant aspects. So for example, constraint programming, formal verification uses a lot of solvers, logic solvers, etc. So went into designing those solvers and constraint programming. And at the moment I am doing some program analysis and formal verification within the space of blockchain, like smart contract verification and things like that.
If I want to talk about how I got into compilers, it's mainly through my course at Indian Institute of Science under Professor Vayan Shrikant and Professor P.P. Shankar. And that's why I got interested, slowly started working when I first joined in Motorola. And then in HP, I was involved for a long time, where I got to know Professor Ramakrishna also, working in HP's compilers, then IBM's compilers. So it was all proprietary, and then I went to work on open source compilers in AMD and moved to work on deep learning compilers, which is kind of the latest fad, if you may say, at Intel. So that's how my career has gone.
Okay, ditto story. Actually, I also got inspired by Professor Preeti Shankar Madam and Professor Vayan Shrikant sir. And then I also joined Hewlett Packard, and my mentor was Dr. Rivendra Das. And then we worked together. I learnt a lot from him. And then I went to a couple of masters, and then completed my PhD from India, France, in corridor compilation, and have been at IIT Hyderabad in compilers group for the past 10 years approximately.
I work
work on compilers for artificial intelligence programming frameworks. Polyblocks is Polymage Labs compiler engine. It's a modern and reusable compiler engine to build a compiler for any high-level programming framework targeted to specialized hardware as well, AI accelerators as well as general-purpose compute chips. Around 2018, I was one of the co-founders of the MLR infrastructure, and I saw a huge opportunity there in terms of building a compiler stack that could provide the toolkit to build new MLAI compilers. And MLR was open source, and I felt this was better done at a startup than at a university lab.
I work on static analysis, which is related to compilers. In static analysis, what we do is we analyze programs to find out if there are any errors in the programs, or we analyze programs in order to automatically transform them, like porting or refactoring or bug detection. So this is called static analysis, where you create tools that will analyze the source code of a program to help programmers either find bugs or change them or improve the program. So static analysis is used widely in the industry. Almost all product development teams use static analysis integrated into the build pipeline so that the bugs are continuously found. And that's my main area of research.
JIT compilers are something that I started looking into when I started my PhD, and I had done courses on compilers, I had read several papers. What I realized was, I don't find any of what exists in the static analysis literature over the last few years that I read about really implemented in a JIT compiler, and that bothered me. That these are compilers used for not only statically typed languages like Java, but then more modern languages like JavaScript, R, Python, all the most popular ones nowadays are being JIT compiled, and now we are not able to take any of what goes in the static analysis literature directly to a JIT compiler. So what motivated me to pursue this is this observation to begin with, where we decided, let's study why are these futuristic compilers still lagging behind, on what things, because of what reasons are static analysis information not being usable, not being found to be usable in a JIT compiler. And we found that it's indeed possible to take it, as we have seen over the last 10 years with some of my group's research. We have been able to take static analysis results, use them, improve them, and then be able to also get the best of both the worlds. Right? On top of that, I would say, we observed after we started working on some of this, initially people reacted by saying, this looks very, this looks to be prone to unsoundness, how can you change the results in different environments. We also found people who found it difficult, who said, it's fine, one person who has a lot of enthusiasm may do it. How do you make sure that more people are able to work across static and JIT compilers, basically across environments, across intermediate representations, and be able to get the best of both the worlds in their implementations? Over time, we have been making frameworks to do all of this. When we improve the situation for one of the optimizations, we also try to generalize it as much as possible so that people in future can do it for more. We found that this way of working with JIT compilers allowed us to collaborate with industry. Industry is very much interested in anything that goes on improving the programs written in these modern languages. And once we started collaborating with the industry, I would say, we really reached the next level, because now we are able to solve problems that stop people from venturing into this space. We are able to solve them in discussion with people who really develop those compilers and are working on them in the industry. And they also say that they, through us, are able to try things that, being in an industry which is focused on each and every new release of the compiler, is not able to experiment and explore things that they wanted to. They are able to do it through us by discussing with us and so on. So I have been sticking with JIT compilers because it's allowing me to go on with the world while learning from each other.
I consider it a privilege to be a part of the program committee for this event. I had been wanting some event of this kind to happen for several years. We tried something called the New Horizons in Compilers in 2001. We ran it for 3 years, but we didn't have critical mass. I had always wanted to create or be a part of an ecosystem, an environment, a forum where people working in compilers, particularly the practitioners working in compilers, come and talk to the academia. So it's been great working on this program committee. We have managed to get the best people working in this field on the committee. So, and even the organizing committee has put in great efforts. And I want this to become a regular affair. Every year, I want this to become a go-to place for everyone who has love for compilers. And I'm looking forward to this becoming a flagship workshop for people who are interested in compilers in future.
When I came today morning to attend this workshop, or even before when I was interacting with other program committee members, I was quote unquote skeptical, because many of these things that you try to do, you start something, either they will be of substandard quality, or I'm being very honest and very blunt, they typically end up as substandard quality, and it's not a effort gets put in by people, but then it's not getting paid back in the right way. But I was proved completely wrong when I came here. I was very happy to see a large number of compiler practitioners, and the interaction was quite intense. And I attended the last session, which was really very good. And I felt that this is a great thing to have started. And I really wish that it continues for many more years. We see a nice bridge here between practitioners and researchers. I think these two communities, if I can say it that way, these two communities look at the problem from two different sides of the coin, right? The researchers look at I wouldn't say theoretical, but the researchers look at the problems, academic problems, and how to solve them, and look at things more from an academic kind of a background, whereas practitioners actually look at real problems that happen, right, when you're implementing some of these things. And I think for quite some time, at least within India, we haven't had fora where these people were interacting with each other. I think this is a perfect forum for that, and I'm very happy to see that that is happening.
Okay. So regarding the experience, I think this is one of the first instances. I think I really feel that we have got a wonderful community of compiler folks, people like you and so many young people. I have known Aditya for some time, and actually I was visiting Santa Clara about a few months back, and Aditya met me there, and we talked about having this conference and what kind of people we can reach out to and stuff like that. And then Professor Kerkar came in, and the other program committee members came in, and it has been a very good experience till now, and I think we should be able to continue this for many years more.
I totally agree. It's like it's fascinating to have this kind of workshop on a yearly basis, at least, to where all compiler folks meet, and then they discuss their ideas, and then this community is only going to grow. So I think it's important that we sustain it. It's very nice of you to start it. Sustaining it is going to be a bigger challenge, but it's not very difficult with young talents like you.
It was quite wonderful experience being part of the program committee of this program. We were pleasantly surprised to find such good quality of submissions for talks, and I was very pleasantly surprised that we could fill such a large auditorium in the name of compiler, where everybody is chasing this ML and AI, that kind of a stuff. So that kind of gives me hope that there will be lot many interesting future edition of the conference. I spoke to a few of the participants, and they indeed mentioned that such conference actually strike a right balance and provides an avenue to collaborate and exchange ideas between academia and industry. So yeah, I believe that there will be lot more additions to this IICT.
Experience being part of the committee. This committee, if I can summarize in one word about this committee, it is enthu. The enthusiasm of the committee members, mostly from industry, and the leadership they took was, I feel that's really good. If we have the enthusiasm from industry and academia joining together, that's very good. As a PC member, we didn't do much, but I really enjoyed that. Yes, we have a group which is excited and which is actually welcoming for all the new students and new compiler engineers who want to take a plunge in this?
So my experience being in the program committee of this compiler technology workshop was very good. I was very surprised to see the high quality of submissions. So I came to learn that there is a very vibrant community in India and in Bangalore working on compilers, mostly from the industry but also from the academia, students, faculty, but with very high presence from the industry. So there is a rich set of jobs around compilers and static analysis in India, which is very heartening to know. And that group of people have come together to arrange this first version of this workshop. And I really applaud them for taking this initiative because it's helpful to the current community and to upcoming students and young people who want an interesting area to work in.
I mean, this program was just amazing. I mean, I couldn't come yesterday, so I just joined today, and I'm completely impressed by the number of people who came, and not only that, the kind of interactions that are happening, the questions that are getting asked. On a Sunday to have so many people discussing about compilers, I mean, this is just way beyond my imagination. I don't think we'll be able to do this in IIT Bombay, get so many people interested in compilers on a Sunday morning. So this is absolutely amazing. I hope that this effort continues every year, and there's a lot of potential.
Today we had a lot of talks. I didn't attend many of them, but when I see the session, there were many talks and other things. That's good. We need to have this, but we also need to have some focused interaction between the practitioners and the researchers. That will actually enable more and more collaboration and interaction, and that can actually bring a whole lot of benefits to the compiler community in India. So I really strongly support that, and to whatever extent possible, I would like to give my support for that, and whatever I can do for that, I would be happy to do that. And I haven't talked about the third part of this community, which is the student, and I think that's an equally important thing. As students, they need to get, they need to be aware of these different areas and opportunities in them, and why they shouldn't run behind jargons, right? That's a very important thing, and I think workshops like this bring that kind of awareness to students, who in turn opt to do things in these areas, or who in turn try to learn and then do things in this area, which is a very important thing. And that's how we can grow this community, and that's how we can have more compiler researchers and practitioners in India. So that's the third part, which is the student part of this workshop, equally important. They may not directly contribute to the workshop as of now, but they getting this awareness and then learning things from here and then subsequently following it up and getting interested is equally important.
One of the reasons why I feel students should learn compilers is learning compilers makes people a much better programmer. So they understand what is likely to happen behind the scenes when they write programs. The second reason is that compilers is the only course in the UG curriculum where they end up writing a really large program. They continuously work on it, on the same program, starting from lexical analysis, syntax analysis. They keep adding phases. So instead of having independent programs, creating one integrated program over a time throws up many design challenges. And I have had students coming back to me at the end of the semester saying, I took this design decision 3 months ago and now I am unable to undo it. This, in my opinion, is a great learning experience, because then later going forward, no matter what they write, they will be careful in designing their code. So yes, learning compilers makes someone a much better programmer. That is the main reason why I think everybody should learn about compilers.
So again, what I would say is that a good majority of the students, they try to go behind jargons, and they think that's what they need to do. Right? In today's context, if you ask, 80% of them would say that I want to do AIML. Right? It is good. You should also do AIML. But then in AIML, there are several other works that you can do to do AIML. systems is an important aspect of AIML, compilers is an important aspect of AML. Unless they get to understand what is in the compilers, they wouldn't really be able to know what they can do in AI and ML.
Yeah, so I believe that compilation, program analysis, etc., it would never go out of style, because there would be always be newer and newer kind of hardware that would come up. For example, we from the traditional hardware, now people are talking about quantum computers. So there would always be, there is one layer of abstraction where the machine will interpret your code, but the level at which we as humans are going to write code or express our constraint and thoughts into programming language, that level is always going to be different. And to enable those programmers who think at different level and translate it into hardware, there will always be need for compilers. And I believe that that's why no matter how much technological advancement happens, because of these two different levels exist, somebody has to bridge the gap, and that would be compiler. And I believe that that's an evergreen field.
I think, some topics in computer science are kind of fundamental. I think compiler is definitely one of them, like computer architecture or OS and things like that. And even though you may think that that is maybe out of fashion or something, you'll always find that gets used some way or the other. Especially as you can now see with the advent of AI, the compilers have taken a lot of center stage. If you look at PyTorch or TensorFlow, they're basically kind of big compilation systems. And you heard, some time back about this quantum stuff. Whenever you are going to go to quantum, again there will be this kind of compilation effort. So I think, knowing compilers and keeping abreast of the technology will help you become a better engineer.
I completely agree. Compilers is not some old subject. It's ever latest subject. It's very, very practical subject, and all the undergrads in CS departments should continue, and then not just stay with the standard parsing, latest optimization, latest frameworks like MLIR, latest optimization, LLVM. That is what they all have to learn. And then we at IIT Hyderabad, we teach them at undergrad level, we teach them LLVM passes, and then we have various varieties of electives, around 10 number of electives on compilers based on compile engineering, compile automations, area of compile automations, topics in compile automations, etc., etc. And then all the undergrads should try to, all the entire community should have, should feel that compilers is a evergreen field, and they should try to pursue this as their future.
Like compilers at IIT Bombay is very interesting. It's basically learning new things at every step.
So we have excellent faculty, my guide Professor Khekar, and other professors like Professor Manas, Professor Pratik, and all the professors out there. So all the discussions, all the presentations, discussions are always in the form of very positive and healthy discussions that we have. So it's actually, be it an progress seminar, be it some examination or something, but it's always a very healthy discussion, and that kind of keeps up the spirit, and it keeps you going and keeps you motivated all day long.
Okay.
It's just like a system with a feedback loop is very important to drive the system. So we have weekly meetings with the professors which give us valuable feedbacks, which helps us to improve ourselves wherever we are falling short of, or if we want to improve our weaknesses. So the faculty is very good and the experience is good.
Next question I can ask is, what are the kind of compiler infrastructures that you work with when you're doing your research or your projects?
Open J9, VM we work with.
What are the various projects that you're working on? Just one line, one word answers if you want to share.
So I'm working on static analysis on Linux. Basically analyzing the entire Linux kernel for basically different optimizations such as pointer analysis and other things.
So maybe the last question I can ask is, how was your experience presenting and attending at IICT?
It was a lot of fun, like the audience was really good and we get to learn a lot.
It was quite good. I got a lot of questions. It was
lot of new things, new concepts.
Okay. The networking was good, the presentation was good, it was a good head start thanks to the organizers, and I hope we keep this going.
Awesome. Okay. Okay, so I think one last question. Why do you think people should pursue compilers?
Interesting, different, and not much people want to actually work in this field. They all want to go to AI. So anyone who is like in the compiler field is actually interested in this field.
I want to say that if everybody writes program, if you want to understand how actually program works, you should take compiler.
Something that my guide actually taught in his class. So compilers is a mix of systems. You need to know everything in systems. There is OS involved, there is enough computer architecture involved, and everything is being interacted by the compiler. So it's basically, if you love systems, then compilers is a perfect place to work on.
So I think this workshop has a bright future. It could become converted into a peer-reviewed conference going forward, along with the workshop. So I think there's a lot of scope for this thing to evolve and to be conducted in different parts of India, hopefully, in subsequent years, and not just in Bangalore. So looking forward to that as well. So I encourage students, young students, BTech students to take the compilers course, study it nicely, compilers and automata theory. These are very closely related courses. So this will help them do research, work in the industry. There are so many compiler related jobs. So do focus on compilers, and also the background for compilers, study discrete maths, graph theory. All these things are automata. These things are very closely related to compilers. And if you are good in compilers, you can get to work in so many compiler related jobs. And not only that, you can also work in static analysis related jobs.
See, compilers, as I said, this poha business, right? If you keep eating it, you will see that, hey, it has impact from every subject in CS. Take any subject, algorithms, data structures, operating systems, architecture, databases, networks, artificial intelligence, machine learning, deep learning. Pick any subject. From compilers and those subjects, there is a, you will easily see they affect each other. Compilers can affect them and get affected by them. You can use compiler related fundas in those subjects, and the fundas of those subjects you can apply. So it's a wonderful sangam of very beautiful ideas across the whole spectrum of computer science. So I'm sure students, if they want to make an impact, they will find this as a beautiful stepping stone.
So this I would actually pitch for every area and every subject. They should learn what are the opportunities in that, and they should try to see how they could, work in these areas. Again, for a student, it's important that they match their interest with their skill set and work in an area. And unless they explore more, they can't really figure out what they are good at or what they would like. And oftentimes what happens is that because of these jargons, because of these things, they get their attention gets skewed to one particular area, which sometimes is not a good thing, right? And that's why I think these awareness kinds of workshops that we conduct, right, outreach kind of workshop that we conduct is very important. You talked about the ACM compiler workshop, which happened several years ago, and you got excited by attending that workshop and learning more. I think those awareness workshops are really important, and students should attend as many of them as possible, not only in the areas where there is a lot of hype or a jargon that's going on, but in other areas as well, just to figure out what else is happening. That's equally important. Right? There are plenty of opportunities in compilers for people to do, not just core compilers, but also in AI, ML, like the talks that we had today. The morning talk was on compilers for AI and ML, and the last talk was ML for compilers and other things. So that kind of shows you the entire spectrum. So plenty of opportunities, lots of things to learn, lots of things to do. So I definitely urge all the students to use up these opportunities and learn more. At the end of the day, it is learning more. That's what is important.
I think it's wonderful. Thank you all for that.
Thank you.